So this part, what we'll be talking in 10 minutes, is actually the advanced integration applications, like including differential equations on kinematics key terms. Let's say we already have done velocity, displacement, velocity, and acceleration relations. We know that if you differentiate displacement, you get velocity. If you differentiate velocity, you get acceleration. If you integrate acceleration, you get velocity function. If you integrate velocity function, you get different the displacement function. So logically, when it is an indefinite integration, there is no problem at all. So if I say there is an acceleration function which is given as 3t plus 5, find out velocity function. When it has been given that at t equals to 0, body is at rest. Body is at rest means at t equals to 0, v is 0. So now here also, guys, now if you see acceleration, try to rewrite it as dv by dt. Wherever you see acceleration can be written as dv by dt. Velocity is ds by dt. Generally, we don't need the backwards for differential equation. But when you integrate dv by dt, actually it is like 3t plus 5. And now actually if you take t here, other sides, it is like dv equals to 3t plus 5 dt. It's like separation of variable, you can say. And then you integrate actually both the sides. Now if I integrate v here, dv will be v, and integration of this will be 3t squared over 2 plus 5t plus c. So you can see that even though knowingly or unknowingly, you're using differential equation skills here. Now, logically, lots of times you'll see the textbooks are not showing this intermediate step. That's okay. If you want to show it, show it. If you don't want to show it, don't show it. Now, next step is to find out the velocity exact function. So 0 equals to 0 plus c. So you get c is also 0. So your velocity function that is given by here will be 3t squared over 2 plus 5t. So you can see how we're using integration to actually drive in to get the velocity function from the acceleration function. But this is actually, if I link up with some of the key terms that you have learned with the area under the graph concept. Now, assume that we have time on x-axis and velocity function on the y-axis. Time on x-axis, velocity function on y-axis. So assume that if I sketch the graph of the function, like not this one, any random function, suppose this is the graph of the function, and if I integrate that velocity function between certain given area, velocity function, if I integrate, let's say v of t, if I integrate with certain bounded condition, a and b, what we get is actually this is the displacement in that time interval. This is called as the displacement in time interval. Displacement. Now, so whenever you have been given an indefinite integration and you just want to find out the expression, you put the plus c. But when you have been given like, okay, velocity function is given by this, and find out the net displacement from time 1 to 5 seconds. In that case, just integrate 1 to 5 and find this value, that's the displacement. So in the area under velocity time graph, we all know is the displacement. But there is something that needs to be taken care very seriously is, I'll give you an example where suppose that this is the function that I'm drawing is for the velocity v of t function, v versus t. So t is on x-axis, v on y-axis. Let's say this is 0, this is 4 here. And what you want to do is you want to find out the net displacement and also net distance travel in the first 5 seconds of the motion. So first 5 seconds, I want to find out the displacement and distance. So now when you have to find out the displacement, now actually you can just integrate velocity function from 0 to 5, and that's going to be your answer. So let's say in this case, if my assume that this function is t squared minus 4t. So v of t function is t squared minus 4t. And if I integrate t squared minus 4t from 0 to 5, which we get is as t cube over 3 minus 2t squared because 4t square over 2, this will be this. No need to put a constant because now putting the values for the limits. It'll be 5q, which is 125 over 3 minus 5 times 25, which is 50. So if you subtract the values, like if you take the LCM of this, which is negative 20, this is 3, 150 on 24, so negative 25 over 3. So the net displacement is actually negative 25 over 3. So um, when you talk about the displacement, you can just directly integrate the given expression between the limits, what has been specified, and you get the answer. But if this would have been the distance, if somebody say, okay, this is the distance, it will be absolutely incorrect. Number one, distance can't be negative. If you even you have moved the slightest bit, you displacement can't be negative. Distance can't be negative, but displacement can be. Now, what does this displacement mean is that it is standing 25 by 3 units to the left of the origin after 5 seconds. That's what I can tell you. Now, what is very important out here is that when I find out the speed, when I find out the distance, I need to take account of speed, not velocity. Now, when I look at speed, actually will be nothing but the absolute value of velocity, which is this will be the speed function if I graph it. So when you want to find out distance travel here, there are multiple ways you can do, of course, but actually you plot the absolute value of velocity function and then integrate it on your calculator also. I would show it to you how to do on your calculator, but 0 to 5, you first plot it, I mean, as the absolute value and then integrate it. The other way was obviously you integrate from 0 to 4 v square minus 4t function, I mean t square minus 4t, normal integration. And you know this answer is going to be negative. So make it positive by multiplying with the negative sign. Because this expression is, you can see area is below x-axis, and any integration that is below x-axis will be negative. So how do I make negative positive? By multiplying with negative. So you keep a negative sign reserved. This answer, whatever it is, multiply. Suppose let's say negative 50, multiply with negative 1 will become positive 50. So that does the same job as the absolute value one. Then comes the second part is like plus this integration will be normal 4 to 5 t square minus 40 because the function is already above the x-axis. Hence, this expression that you got will be the net distance traveled by the body. Now, I'll just show it to you how to do the same thing on a calculator. So when you are looking forward to doing such same questions on calculator, you just straight away go to the graph. You plot the graph of the function. So let's say x squared minus 4x is the function. So x squared minus 4x, you plot the graph, and then you plot. So suppose if you want to find out the displacement directly in the first 5 seconds, you just do gsol, then you press integrate, integrate, integrate. Just type out the value 0 and 5. So you can see that this answer negative 25 over 3 we had got, which is negative 8.33. That's your net displacement. How about the net distance is basically you plot the absolute value, option, numeric, absolute of, you can manually type the function or you can just type out as y1, and you can deselect the first function. And here goes, is your now speed function. So when you're doing the area now here, you can just do the integrate 0, type of the lower value is 0, upper value is 5, and you'll see that the net distance travel is around 13 units. So this is the difference between distance and displacement, and if you integrate the velocity function blindly, it is not going to help you. So it is important that you integrate with your presence of mind when it comes to the problem on velocity to displacement. Displacement to velocity is derivative, but acceleration to velocity. Now, any definite integral, when you put for the limit, let it be for acceleration. If I have acceleration time graph, let's say a of t, if I have a of t, if I look at a of t graph, suppose has been given to us, and when I find out the area under certain time for this graph, let's say 1 to 3, this will be the change in velocity in that time, change in velocity. So whenever you put indefinite integration, it is going to give you the expression. But when you put the limits for that integral, it is always going to give you the distance or displacement in the time interval depending upon the type of function that you have. So this is the basic clarification about the kinematics integration concepts. And so as a summary, you can remember that. Uh, so suppose if you have displacement, velocity, acceleration, if you integrate acceleration expression, you get velocity. If you integrate velocity expression, you get displacement. But if you put the limits a and b, you get change in velocity in that time interval. And if you put limit a to b, you get change in displacement. It means that net displacement in that time, as you saw in the previous example. So this is the integration concept that is hidden in the kinematics.